Hello everyone, this video introduces the backend function of the restaurant review social app. First, look at the project model. As shown in this figure, Nginx server port is A080, stores static web resources and performs reverse proxy functions. Port number of the server is A081. Detailed functions are described later. This circle field is used to import the MySQL form and the related data that we need. Next, let's introduce the relevant function of this project based on Redis one by one. First of all, introduce the user's SMS login process. Enter the mobile phone number in SMS login interface and select I have read and agree and click send verification code button. The entered phone number is returned to a 6-digit verification code like this. Which is also stored in Redis. This is the login code. The login process after enter the verification code and click the login is shown in this flow chart. The login user will be stored in Redis in hash form, and the login user will be directly obtained from Redis, and the login verification will be performed. The token will be stored in this form. We can see this the user, the login token. We set up two login interceptors. One intercepts all paths to verify the login token process, and the other intercepts the path that needs to be logged in to determine whether the current user is logged in. The functional model is shown in this figure. Okay, after landing on the app, you can see that above is classification of the shop, and the following is the customer shop visit notes. Click shop category to view the list of shops under that category. Both category and the list of shops are cached in Redis as string. We can look at records in Redis and we can see the expiration time here. This is the shop cache and the expire time. And this is the shop type cache. There are two Redis cache models. If the consistency requirement is not high, the memory elimination mechanism can be used. If the pursuit of high consistency can adapt the way of achieve update and timeout elimination as a backstop scheme, this project adapt the latter. Let's look at a flowchart of the shop cache. We first query date from the cache if it is not in the cache, then query database. Cache the date from the database into Redis and return the query result. When updating a database, there are three problems. The first is the inconsistency between database and cache. My approach is to delete the corresponding cache date directly, then the database is updated and recache it to Redis when the data is queried. This approach not only ensures data consistency but also reduces the number of cache writes. The second problem is the transaction problem. If it is a single system, it is necessary to put a database and a cache in the same transaction. If it is a distributed system, it is necessary to use TCC distributed transactions. The last question is which database or cache operates first. Because the performance of the cache is higher than that of the databases, the probability of date update error caused by the operation of the cache first is much higher than that of the database first. Therefore, we choose to update the database first and then delete the cache. When we modify the restaurant name with post1, we can see that the database has been modified and the cache has been deleted. Then we can query the restaurant date again and see that the cache has been successfully added. Let me show you. We can use the postman and we modify the name of 101 cafe to 102 cafe. And we can see the MySQL having already changed. And we see the Redis. The ID is 1. Has already been deleted. We can see the ID 2 has also existed. And we query it in browser. And we can see the cache has been changed to 102. Okay, two other problems with caching are cache penetration and cache breakdown. Cache penetration is when the data requested by the user does not exist in the cache and the databases, and constantly making such requests puts a huge strain on the databases. There are many ways to solve this problem, such as Bloom filter or increasing the complexity of IDs. I use a method of caching non-values. Looking at the databases and Redis, we can see We can see that there are no shop with ID 0. We now directly query the shop with ID 0. And we can see that Redis add the corresponding cache and return a none value. Okay, the cache breakdown problem is that a key with high concurrent access suddenly fails, and the countless requests for access will have a huge impact on the databases in an instant. There are two ways to solve this problem. One is to add a mute lock. The logical flow diagram shows in this figure. The advantage is no additional memory consumptions to ensure consistency and simple implementation. The disadvantage is the risk of deadlock and can only be executed serial. Performance is affected. Let us use JMeter to demonstrate the performance of mute under concurrent conditions. We simulate 1000 thread and set the time to 5 seconds to access shop 1 at the same time. Delete shop 1's cache. And we clean the log. And send the request. You can see that the database is accessed only once, proving that the database is not under great stress even if the cache fails. Okay, another solution is logic is variation, and the logic flowchart is shown in the figure. The advantage is that performance is good. There is an additional thread to hold the log to reconstruct the date, but the other thread can only return the previous date until the reconstruction date is complete. We also tested with gmaster because the key has no expiration time in logical expiration mode and is only updated according to the logical time. We first modify the database. We can see that 101 And in the Redis is also 101. We modify the database 102. And then set a start time to, and then set the 100 thread to 1 second and send the request. You can see that the database is only accessed once, and the data in the cache is 102, 102. And the data in the cache is 101 at once. 101 at once, and after a while, it became 102. Okay, then let's take a look at the coupon flash sale feature, which we can create through Postman. For example, we can create a special 100 voucher. The voucher costs 80 yuan and can be used for store purchase, equivalent to spending over 100 yuan minus 20 yuan. I have already created the coupon in advance, and the valid date of the coupon is from March 1 to April 1. In the user interface, we can purchase this voucher by clicking the flash sale button. We set the voucher inventory to 100. At first, we clear all the orders, and we set inventory to 100. We also need modify the Redis, delete the order, and set inventory. And we can see there are 100 vouchers. We click the button. We can see we buy it successful. And the inventory become 99. And there create a new order. No one is allowed to buy only one. That is a maximum of 100 users can participate in this event. Click on flash sale, you can see that the purchase was successful and can not buy again. We have already buy this. This user have already buy this voucher, so it cannot buy again. This flowchart of the order is shown in the figure. We need to judge two issues. One is whether the buying time has begun, and the other is whether the coupon inventory is sufficient. In the case of high concurrency, we need to consider two problems. First, in the cluster environment, one person, one order problem. That is, the same account can only buy one voucher. One person, one order flow chart is shown in the figure of this. We use Redisson distributed lock as pessimistic lock, regardless of whether any thread needs to obtain a lock before manipulating date, ensure that the thread executes in serial. The second is the problem of oversold inventory. That is, we set the inventory to 100 and can only sell 100 orders at most. The flowchart for solving the problem of oversold inventory is shown in this picture. We use an optimistic log approach only when updating the date to determine whether other threads have made a change to the date, using Lua script to judge the voucher inventory and the verified function of one person, one order to ensure the consistency of databases and cache transactions. If Redis returns 0 to prove that an order can be placed, the order is pushed to the message queue to realize the asynchronous order function. Below, we use the asynchronous buying process. Below, we use a JMeter to test whether the data in the database cache are correct when the same account places 200 orders at the same time and 1,000 different accounts place orders at the same time. For 200 orders with the same account, JMeter starts 200 threads, set the time to 0. Authorization to one account. Redis and MySQL inventory to 100 and clear all orders. Click start and we can see there's just one orders. And the stock is 199 in Redis. The stock is same with the MySQL. And they just have one orders. The user ID is 1. The user ID is 1. We can see same with our user. Then to test 1000 accounts at the same time to place orders, I'll create 1000 accounts in my MySQL at once. 1000 rows selected. And use this test program to generate the corresponding tokens of these 1000 users to write in this field. In this field. And the key corresponding to tokens is written into Redis. In Redis have already logged in 1000 users corresponding to MySQL. Then JMeter creates 1000 thread to read the 1000 tokens and execute the order. $1,000 thread at the same time. And we clear the order. Set stock to 200. We also need to modify the Redis, the data in the Redis. And we run the thread. We can see they generate 200 orders. And the stock is 0. The Redis is same with the MySQL. They have 200 orders. in the Redis stream message queue, there have the order message. The above tasks provide successful in solving the problem of oversold and one person, one order. Okay, let's take a look at nodes function. Click the plus button. Users can post their own shop notes. You can upload a picture of the shop. To write a node title, and restaurant experience. And associate the corresponding shop. For example, we associate with 102 cafe and publish. We can see this node have already published. The node can be viewed by other users after they are published. Users can like the content of nodes, and the leads are sorted by the number of likes. We can see this node's sort is up. And when we viewing the node, we can see which users have liked the nodes. We use the Z side of Redis to store users who have liked the nodes and display the top 5 users who have liked the nodes first in the order of liking time. You can see these 2 users have liked this node. When we will introduce the friends follow function. We can follow a user or unfollow a user. Using the Redis set date type implementation, different users can follow each other or unfollow each other. And in the following bar, you can view the store nodes posted by the following user. This user have already followed this, so he can receive this user's dynamic. And use the intersection feature of site to view the common friends between users. We can see their common friend is this user. We can see the user's following relationship in Redis. The user 2 have 2 followers, the user 1 and user 5. And the user 1 have the user 2 and 5. The 5 have 1 and 2. So the 1, 2, and 5, they are following each other. We log into each of the 3 users and could see the nodes posted by the user they followed. We log in the user 2. User 2, and we can see the node published by the user 1. In addition, the feed stream mode is implemented with Z-side, and published content is pushed to the fan inbox according to the timeline. They are sorted by the publish time. Finally, we use the function of GEO date structure time short by distance. They are sorted by the number of comments. They are sorted by the score. And they are sorted by the distance. The top one is the nearest restaurant. Okay, so to sum up are the main function of this project.